How we doing, 171 guys? Listen, we're doing we just finished up axles. I did my last video on axles on progressive couplers and locking style limited slip differentials. But what we're going to get into now is chapters 15 and 16 in the new book. Not sure what it is in the old book, but it's four-wheel drive and all-wheel drive systems. And then there's a section on the same four-wheel drive diagnosis and service. So I want you guys to go through, read those two chapters, make sure you're familiar with the material. You're going to need to know that stuff, I guess, for the final. Plus, you know, it's something you want to know how to do. But four-wheel drive systems and all-wheel drive system, I should really start there. What is the difference between a four-wheel drive and an all-wheel drive system? Again, we could be in a discussion for hours on this one, but basically a four-wheel drive system has the ability to drive all four wheels, and it is usually selectable, which means that it's in a truck application where you can go into two-wheel drive. Sometimes you can go to four-wheel drive low, you go to four-wheel drive high, and then you've got the two-wheel drive selection. In an all-wheel drive application, that's usually something that's on all the time. That's more of a sport utility feature. That's more of a passenger car feature. It could be in a truck. My Jeep has an all-wheel drive system, but basically what that means is you're in it all the time. You drive around and you don't have to worry about shifting in and out. Some vehicles don't even have a shifter. You're just all-wheel drive. And what they're basically doing there in an all-wheel drive system is they're using progressive couplers within the transfer case to drive both the front and rear axle at different speeds. So it'll go around a turn, but engage if there's enough of a slip. And the same thing usually occurs at the differential itself. So they have a progressive coupler there too. So if you do get into a situation where wheels start to slip, they can engage those wheels and take off. In a four-wheel drive system, you either drive it in two-wheel drive. If you put it in four-wheel drive, there's probably a warning on the visor that says, be careful if you're running this car in four-wheel drive and you try to drive on a solid surface. It could be dangerous because now it's trying to drive the front and rear axle at the same speed and both wheels at the same speed, and you try to turn, it's going to bind. So four-wheel drive applications are great. They're more of an aggressive style of system. And then you got your all-wheel drive system, which is, you know, just getting in and drive it. If you got a minivan that's all-wheel drive, you don't have to worry about shifting in and out. You have to lock in the hubs or do any of that stuff. You basically just drive it. But the reality is there are two major types of four-wheel drive systems. There's a part-time four-wheel drive, and there's a full-time four-wheel drive. A full-time four-wheel drive, you can put it in full-time four-wheel drive and drive it all the time. That's going to make that an all-wheel drive system, limited transfer of power, but it's going to have a limited slip device to engage. It's going to have a progressive coupler to engage, and that's what they call a full-time four-wheel drive. A part-time four-wheel drive is, I just got stuck in my neighbor's backyard. Holy crap! Looks like he's waking up. I got to get the hell out of here. So a part-time four-wheel drive, you engage it. You just turn every wheel at the same speed and hope for the best, okay, and get the heck out of there. That's a part-time four-wheel drive. Not recommended for highway use. If you do a part-time four-wheel drive, you got to make sure you're either on wet or snow pavement, so you get a little slip in where the tires will slide, or you're just never getting your parking spot. So that's a part-time four-wheel drive. So full-time four-wheel drive is all-wheel drive, and then part-time four-wheel drive is, oh boy, I'm stuck. So your part-time guys are your off-roaders. Your full-time guys are on the road. Okay, so those are the differences between the two. So read through this chapter. It talks a lot about how they configured them. A lot of cars are the trend now is to take a front-wheel drive vehicle, put a power transfer unit on one of the axle shafts, and then drive the rear of the vehicle. I shouldn't have said one of the axle shafts because it actually drives off the differential. But it looks like it's driving off an axle shaft, but it actually sets on the output of one of the drive axles on a transfer or a transaxle. And what it does is it drives a tiny little differential in the back of the car. And what that does is it allows for an all-wheel drive or four-wheel drive system if the front wheels slip. So the front wheels slip and so crap, the rear wheels will drive and engage. That's a front-wheel drive transaxle in an all-wheel drive. It's easy conversion. Manufacturers love it because they can build a whole bunch of front-wheel drive cars and then maybe a couple of all-wheel drive versions and don't have to restructure the entire powertrain. So that's been the trend, okay, to do something like that. A transaxle with a power transfer unit that drives a rear differential if needed to get you the heck out of that icy patch in the Walmart's parking lot. So that's going to be a front-wheel drive transaxle kind of passenger car sport utility. And what gets me is a lot of the Jeep vehicles, the Compass and some of these, you know, I don't know what they call the new Jeeps, you know, they're trail rated. The reality is it's not a Jeep. But they pass them off, put Jeep stickers, tell them they're trail rated, and they got like that much ground clearance. It's just horrible things. But what they'll do is they'll take a transaxle, front-wheel drive, transverse mounted, and then put a little goofy shaft to the back and drive the back of it and call it four-wheel drive, and you know, it just really isn't. So that's one configuration. The other configuration would be a conventional longitudinally mounted engine that feeds a transfer case. Now, a transfer case is a big chunk of stuff that sits between the engine and the rear axle, or the transmission and the rear axle. And what the transfer case does is takes normal power output that would go to a rear-wheel drive differential and powers a transfer case that changes the direction and sends some power up front to a front axle assembly or front differential in a four-wheel drive vehicle. That's a true four-wheel drive truck. Okay, and that's what you'd see. Put a truck in the air and you get this big chunk in there. It's called a transfer case. Today's vehicles, the transfer cases are all chain driven, so they got this big massive chain that drives basically another pinion shaft that runs a front differential. So that's a transfer case. Okay, and that's how they run it. Now those transfer cases are cool. They can actually be a mechanical lock, so it's either four-wheel drive part-time or two-wheel drive. Or maybe even four-wheel drive low. Some actually put a gear reduction unit in there that allows for a lower, like a 2.7 to 1 gear reduction in the transfer case, which is neat. Okay, so that's what a transfer case does. Pretty neat little unit. And then some of them will actually use a progressive coupler, so they're kind of all-wheel drive. So that's what my Jeep has. It's got a 247 transfer case, but I put a progressive coupler in it, so that actually will feed the front axle if needed. And if it's not needed, it just doesn't apply. So it's a really sweet system. So, those are different things. So read through this chapter on transfer cases. They do get into a little bit talking about locking hubs. Locking hubs I don't think there's too many manufacturers. I don't know if anybody really does the locking hub thing anymore. But what locking hubs allows you to do is turn off the front axle at the hub, at the wheel, and then put the transfer case in the two-wheel drive. And it just gave you better gas mileage. That was the whole purpose behind it. You don't have all that stuff spinning in your vehicle. If you go into four-wheel drive, now you got to put the shifter inside the vehicle into four-wheel drive, and then get out in the snow and lock your hubs. Kind of a disadvantage to the customer. Now they got to get out and do it. A lot of manufacturers, and they do this. Ford does it. They have a vacuum actuator that engages and disengages the hub now. Well, that's hasn't been a great system. So that uses a little vacuum servo, but I mean that's it's what people wanted. Didn't want to get out there and physically engage and disengage. But the only purpose of the locking hubs is to get a little better gas mileage. That's it. Because you can put the car in two-wheel drive with the transfer case. But if I was in a two-wheel drive situation with an unlocked hub or a locked hub, what would happen is you just have to drive all that stuff going down the road. All that stuff would have to spin. By unlocking the hub, now you don't have to spin any of that stuff. So that's the purpose of the locking hub, is just a little better gas mileage. Some manufacturers use a front vacuum actuated front axle disconnect. It's in the book. We've gotten away from a lot of this stuff, but this is kind of the history of four-wheel drive systems. They used, some of them used a vacuum actuator, or some of them used a mechanical link that would engage and disengage, electronic solenoids, and all kinds of things to break on these cars. So this chapter will take you through kind of the history of some of these four-wheel drive systems. You're going to hear about progressive couplers. They use what they call a viscous coupler, which is a clutch pack that would get hot, expand, and engage. And then there's another one that's called a hydrolock system. You use a little hydraulic pump to apply clutches. Both of those are progressive style couplers. There's a couple in here. There's one I think they're talking about here. It's called a electro-hydraulic coupler. So again, there's quite a few variations to this. But over the years, they kind of get away from it. Where they're really getting away from this is they're using the braking system to apply a wheel that's spinning. So your stability control, your traction control, your braking system can now apply hydraulic pressure to a wheel that's spinning that'll get you up out of the hole. Because if you got a wheel sitting, you got an open differential and the wheel spinning, if I apply the brake to that wheel, it's going to transfer power to the other wheel that's on the pavement. So that's what most manufacturers are using now. They're kind of getting away from all these things because it all broke. Okay, but this is a pretty good chapter. It'll take you through those systems. So make sure you read this section because I think I got a couple of questions on the final on this guy. So, okay, cool. Plus, you live in the Northeast, and we get 200 freaking inches of snow. So you need to understand how four-wheel drive systems work. Okay, thanks.